I will go over every software design pattern there is and rank them. Look, every line of code you write adds to your technical depth. No exception. Some code adds just a little, like a little chocolate bar as a checkout. You know you shouldn't, but hey, it's a small treat, right? But then, oh boy, some code adds a huge chunk of technical debt, equivalent to buying a fancy sports car on a student's job salary. Not a good idea. And technical debt is one of the main factors that can bring your project to a slow and painful pace, not to say death. No one wants that. We want to develop fast, be flexible, to quickly implement new features, improve existing systems, find and fix bugs easily, and if the game is successful and lives long, we don't want to suffer maintaining it. And for having an enjoyable codebase with a manageable technical debt, we need some design patterns. Do we need all of them? We will see. Design patterns fall into three categories: creational, structural, and behavioral. For each category, I will take one design pattern at a time, explain it shortly, give you some examples, and share some slightly biased and sometimes strong opinions. I won't teach you how every pattern works in detail, forget about that. If you like a pattern very much, I put some links in the description with some resources. Let's get to work. The first 5 patterns are all about creating objects. The factory is there to create products. What it does, it decouples the creation or initialization from the product itself. Let's say you have a character class. It can be abstract or an interface, doesn't matter. And concrete implementations as warrior and wizard, for example. Now you need to have a character factory and concrete implementations as warrior factory and wizard factory. How to create a character and what happens at that moment is taken care in the factory. The warrior might shout a war cry when spawning, and the wizard might play some special effects. See, the code to create products is decoupled from the product itself. In this example, the characters are the products. Spawning things in game is, kind of essential. You either instantiate new objects or you use an object pool. And if you need to create lots of different objects that are from the same family or factory, well, then this pattern could help you out if you are working in an object-oriented language like C# or Java. But man, factories, I warn you, this can get out of hand pretty quickly. Let's put this in beat here. Oh no, already this. Next pattern is an abstract factory. Let's take the example from before. Warriors and wizards. Now add one more dimension, like humans, elves and orcs. You could have elves warriors, human warriors, wizard elves, and so on. The abstract factory is kind of an extension of the factory method. You would then have a human factory, elves factory, orc factory. All those factories are subclasses of the same abstract factory, and each one creates their own products, following a common interface. This pattern starts to add a lot of classes to your project. That's a lot of factories. If you have lots of products and lots of families of products, where the creation is really different from each combination, I might consider using this pattern. It can also be useful if you are building UIs that are fundamentally different for each platform or scenarios, like having a standard UI factory and an accessibility UI factory, where each UI component needs to work differently for accessibility reasons, for example. But I'm telling you, I also do a lot of Java, and there you can find an abstract Singleton proxy factory bean. It's not a joke, Google it. And so when I read abstract combined with another term, I'm not feeling very well. This goes C tier. It has its uses, but I don't have to like it. Next, we have the builder. If you need to build a complex object where you have lots of possible options, this will come in handy. Let's say that your game can generate random rooms, and everything in that room can be configured. The walls, the windows, the furniture, the decoration, and the enemies inside. You can end up with a giant constructor and even many constructors, and that's really unreadable. So this pattern introduces a builder class. You create a builder, and instead of smashing all in an ugly constructor, you configure your object step by step, and at the end, you build it and get your object. I'm inclined to put this in S tier because I find it quite elegant, but because I hesitate, it means it's not quite S tier, it's A tier. It's definitely above the factory, like you can use a builder instead of the factory in many cases. Next pattern is the prototype pattern, and I'll go fast over this one because it's not so relevant for Unity. When you want to copy an object, you have to know everything about the object you try to copy, including private fields, which might be a problem. The prototype pattern has basically two parts. It delegates the copy or cloning to the object itself, so you can tell the object, well, clone yourself. And the other part is that you have pre-built objects called prototypes that you store in some prototype registry, and whenever you want to have a specific object, you create a clone from that registry. This pattern is useful if the creation and configuration of objects is complex. Now, this sounds a lot like prefabs. Pre-configured, complex objects that are super easy to clone. Prefabs are prototypes. They are really helpful. And I've seen people never use any prefabs. It exists. I'll put this in S tier because instantiating from prefabs is just everyday Unity stuff. But I'll add a little Unity logo on this just to say that, well, this pattern is already in use. And the last pattern for the creational category, the most known, most abused, and probably most hated of all. I'm of course talking about the Singleton design pattern. Every newbie, but also many pros uses it. You can create a game manager, a score manager, or any kind of manager and access it from anywhere you want. I get it, it's really convenient. But Singleton's main feature is to ensure that one instance of a particular object exists at any moment. Which in Unity you probably don't care much because you always call myManager.instance and you have control over your code, and you would need to write really bad code in order to create two instances of something you know you want just one instance of. Now, why are singletons hated on? In my opinion, the hate on singletons is a mix of bad experiences and ego. It's stupidly convenient to be able to access a global state. It doesn't make it bad. It's perfectly normal to have managers or services, let's call them, accessible from everywhere. Think of a database service to run queries, an analytics service to track what the user is doing, or an error or logging service to handle stuff. Those might be accessed through singletons or even through dependency injection, which is essentially the same as saying, I don't use singletons, but I can inject my services everywhere at will. Now, remember the intro about technical debt? A singleton by itself does not really add a large amount of technical debt. What adds a lot of technical debt is not respecting the single responsibility principle. Having singletons or anything else that does more than it should is a real problem. I'll make many people upset and I'll put singletons in the A tier. If you know what you are doing and don't abuse it, meaning that you don't singletonize everything, it's an extremely convenient pattern. Not perfect though. That's all for the creational patterns. At this point, if your brain is not yet fried from all the patterns, then congratulations, you might qualify as a true programmer and a design pattern lover. And just before we continue, leave a like and make sure you are subscribed because new videos might go in crazier directions than this one. Next up, we have the structural patterns. Here, it's all about assembling objects and classes into larger structures. First in the list is the adapt pattern. Its only purpose is to make two incompatible interfaces work together. It's basically kind of a wrapper, but you make it fit your existing interfaces. Not to confuse with the Facade pattern, which we will cover later on. There you create a new interface. The adapter is useful to make a third-party library work with whatever existing code base you have. Here's an example. Let's say you use Unity's rigid body and after 3 months you download a new kind of physics engine and all methods are different. It's not add force but apply force, for example. And this for every method. Now you could rewrite all your code or you can create an adapter. You create a custom rigid body, extending rigid body and re-implement every method to use what that third-party library uses. So on the client side, you still use a rigid body interface, but behind the scene, it's actually the third-party one. The client code is not changed. That's the main use of this. Where should we put this one? It's a way to wrap code. It's not my favorite wrapper because you are reusing existing interfaces. And if the premise is you chose a third-party library with an incompatible interface, chances are you anyway will need new methods that make use of the unique features of that library. Maybe that library has an apply force with curve, I don't know. I'm not a fan of pressing something into a shape it wasn't meant to be, so I'll put this on C tier. It's not D tier, just because I still give it some wrapper creds. Next we have the bridge. This one is pretty simple. You create an abstraction layer to delegate work to the actual implementation. I give you a very basic example. Let's take our warrior class. The warrior might have a one-handed sword or a two-handed sword or a shield or whatever. I'm sure you see where this is going. We create an abstraction layer, handheld weapon, for example, and implement one-hand sword, two-hand sword, shield, and so on. This is basic object-oriented programming. Actually, this is fundamental. Let's put this in S tier directly. This one is also fun. I even covered it in another video. So, the composite design pattern says, compose your objects into a tree-like structure and then work with these structures as if they were individual objects. Mono behaviors promote the composite pattern. The tree structure is your hierarchy. Each object can have any number of mono behaviors, and most of the time you have a kind of a main mono behavior at the root that acts as the boss of the tree. To keep it short, don't be afraid to use lots of mono behaviors, and if you want more details on that one, check my other video. For Unity, working with hierarchies and lots of small mono behaviors is how it was designed. If you do it right, it makes your objects easy to, well, compose. I'll put this in A tier because overall it's a complex pattern to work with, and I add the Unity logo because mono behaviors. Next up, we have the Decorator. It's an alternative to subclassing. Usually you extend the functionality of a class through inheritance, but inheritance works only with one parent. What if you need the behavior of multiple objects? Well, the Decorator works by placing objects inside special wrapper objects that contain the behavior, and you can repeat this wrapping for as many behaviors as you want. I tell you now, I didn't find any convincing argument why this pattern is any good. Let's imagine we have our player and we want to track all accumulating effects of its armor, weapons and skills. Using this pattern, we would have a class base stats with, for example, values of HP, armor and strength, and an abstract class base stat decorator that extends base stats and has a reference to a base stats. Then for each item we would have an implementation of that base stats decorator, and the magic is that you have to implement the method so that it is aggregating. Then you can create new decorator instances by passing the previous decorated class. It works like a stack of behaviors. I hate this. If I want a stack, I create a stack. If I want a list, I create a list. I don't want to wrap my wrapped objects into another wrapper and then make each method call super to make sure everything propagates up or down the stack. I find this pattern horrible. It's D tier. Alright, let's calm down and look at the facade pattern. This one is very simple and very useful. You basically hide a complex system behind a nice and simplified interface. That's your facade. There's nothing fancy about it. Let's take a save system. Saving can be really complex and you might have a lot of things to save. Well, you create a facade that has a few simple methods like save, load, new game, and it's super trivial to use. I am a big fan of the facade pattern because I like to create simple interfaces and make sure every system takes care of its own stuff. So at the end, I'll have lots of systems, but the front-facing part is intuitive to use. S tier for me. Let's move on to the Flyweight. You might be using this one without knowing. Let's say you have tons of enemies and each enemy has some stats, like starting HP, strength, speed, and so on. And each type of enemy has the same stats. You would probably put that as public fields on its mono behavior. Well, that's bad and you should feel bad. Instead, the Flyweight pattern says to move the common parts somewhere else and have all objects share that. In Unity, you can do that with scriptable objects. So you define your enemy types as scriptable objects and each enemy references one scriptable object. That's it, data is shared. Scriptable objects are awesome. This is definitely S tier, share and reuse as much data as possible. I love this. And now our final contestant for the structural pattern, the proxy pattern. It's yet another way to wrap things, and there are many ways to use this pattern. It's called a proxy because it positions itself in front of another service, does some extra things and calls the service behind. Yes, it looks like an adapter, it looks like a facade. I didn't invent design patterns, okay? For every slight variation, a new pattern has been created. Anyway, there are many use cases, I'll go over two of them. First, let's say that you use Unity gaming services, but some API calls are slow, others cost money. You could create a Proxy gaming service class that has some smart optimizations and caching and still uses Unity gaming services. So the interface is identical to Unity gaming services, it's just that everything passes through your proxy first. Now for the second example, let's stay in the same domain. Let's say that you don't want to always test your game with a real Unity gaming services. You could create a mock Unity gaming services as a proxy. In this case, the mock class implements the same methods as Unity gaming services provides, but the proxy is not forwarding any request. It directly returns fake or mock data. That's very handy for development when not all systems are ready to be used. I put the Facade as an S tier. The proxy pattern is so close that it is just fair to put it next to it. Both are really close buddies. Alright, 2 categories down, 1 more to go. By the way, I have a Discord server. It's called the GameDev Kingdom. We discuss this type of nerdy content as well as all kinds of game dev topics. Link is below. Now let's go over 11 behavioral patterns, and I tell you already, some have lots of similarities. The first behavioral pattern is called chain of responsibility. Basically, a request goes through a chain of handlers, and each handler decides to process a request or pass it on. This is useful when you need a sequence of checks. There are 2 ways for implementing this pattern. In the first implementation, all handlers perform their work and pass the request to the next handler. The second implementation is that as soon as a handler can handle the request stops propagating. Is this useful for games? Yes, definitely. It can substitute big if-else statements or even better switch cases. Imagine a sequence of sensor checks for an AI system. The AI hears a noise, this triggers the chain. First check is check if the location the noise comes from is accessible to me. Yes. Second check, go there and check if something is unusual. Once he arrives, third check, is there a clue that can point me to another location to investigate? Now, because you have those handler classes, you can change the sequence of those handlers. Maybe one enemy starts shooting directly, empties his full mag and then thinks and investigates. This logic will be a matter of rearranging the handlers. I'm used to such patterns in backend development, less in game development. I'm not sure I would choose this pattern when I know that there are other patterns I would prefer for similar use cases. So, C tier. Next on the list, we have the command pattern. The idea of this one is to turn a request, like a method call, into a standalone object that will do all the work. So now that the method is an object, you can do new things like delay it, put it on a queue, keep it on a stack, and perform an undo. To give you a concrete example, let's say you have little workers. Each worker can collect, carry, and build. Instead of calling worker1.collect, vector tree location, you would have a collect command object that you add to the worker's task queue. There are many more use cases. You can use this to allow players to rebind UI buttons. This is a good pattern, pretty simple to understand and manage. In Unity, you can argue that coroutines kind of falls into this pattern as well. I mean, kind of. I don't think you need this in every game. I will keep it in A tier. Next pattern is the Iterator. It basically allows you to iterate over objects without dealing with the underlying structure. You might think, hey, I work with lists or stacks most of the time. Those are easy to iterate over. And yes, you are right. This pattern is in case the underlying structure is a tree or a graph or anything else. And in the majority of programming languages, basic iterators are already there. I don't know for you, but I loop over things very often, and I never felt the need to implement my own iterator pattern. This is more niche and might be useful when you work with complex data structures. I put this in the lowest tier because I don't want to deal with this. I want iterators built in and ready to use. Next one is Interpreter. It is meant to be used to develop language interpreters or compilers. Not very relevant for game development, except if you are writing your own language, so I'll put this in D tier for that reason. Next up, we have the Mediator. It's also known as the intermediary or controller. Let's say you have many objects that need to work together. Well, you don't allow them to work together. You put a controller in the middle and everybody talks to that. This is also how mono behaviors are used. They are kind of controllers or managers and have references to many other components. And the mono behavior might handle the collaboration between components. So you are using this pattern already. Every Unity tutorial uses this pattern. Now, how good of a pattern is it? I don't think it's S tier because each mediator or controller bears the risk of becoming a huge class with tons of references to other components. Then there is the fact that this pattern is pretty generic. It can be applied in many different ways. For that reason, it is going to be A tier, and I add the Unity logo because mono behaviors. Alright, let's move on to the Memento pattern. This pattern lets you save the state of an object and restore it at a later time. And it does this without breaking rules of encapsulation. This means that every object handles its own stuff. In practice, the object that you want to save will implement the method to create a snapshot. It's a copy of itself at that moment. The snapshot data is stored in a new object called a memento. Then you have the so-called caretakers that take care of the memento. It keeps track of all of them, saves them to disk and so on, but never touches the data inside. Those behavioral patterns are tough to rank. Save and load is often a big pain. This pattern helps organize it. I think it should be A tier. Are you new here? Should I really introduce this pattern? I'm a big fan of publish subscribe systems. I made an entire video on building an event system using scriptable objects. This is S tier. All day long, one of the best ways to keep systems completely decoupled from each other. I love events. Next pattern is a state pattern. We are talking about finite state machines of any kind. It could be a simple FSM or a full-fledged behavior tree. By the way, I also have a video about state machines. The state pattern is GameDev 101. However, I'm going to put it in A tier because even though it's super powerful, it can quickly become quite complicated. Transitions and states can be difficult to debug, and without a visual representation, well, you can easily get crazy when working with 10 plus states. Next up, we have the strategy pattern. The idea here is to extract different algorithms into their own classes called strategies. And then you can easily select which strategy you want to use at runtime. There is nothing special about this one. Like many other patterns, it delegates work to a subclass. It is also very similar to the command pattern. The difference lies in the fact that each strategy solves the same problem in different ways. For the command pattern, each command solves a different problem. Now, at the base, it's just an interface with subclasses that implement that interface. In Unity, you could even implement this pattern using scriptable objects, where each strategy is a scriptable object and each asset can have different configurations. It's useful for abilities or AI attack strategies, for example. The beauty of OOP. Other patterns provide a similar structure. The difference is really how things are called, really. I'm still putting this in S tier because it's fundamental. Second last pattern is the template method. I think the best way to explain this pattern is through mono behaviors. Again, the template method defines a skeleton of an algorithm. That's the mono behavior class. And then you can subclass it and override specific steps of the algorithm. But you are not allowed to change the structure of the algorithm. Mono behaviors give you awake, start, update, fixed update, and some more. They are all part of a specific algorithm. It's fixed, and you can't say, for example, well, let's call awake after start. It's not allowed. The same pattern can be found when you implement a custom state machine behavior for the animator. We are using Unity. This pattern is present at many places. Now, would I implement this pattern in other ways for my own game? I don't think so. I think it's a useful pattern when you create a library that is meant to be used by other developers and you want to let them inject their logic into specific steps, but not allow them to change the logic of when those steps are called. For that, it's B tier. Alright, let's finish strong with the visitor pattern. This one is interesting to me. What it tries to solve is separate the algorithm from the object on which it operates. The algorithm pays the object a visit just to know who it is. Imagine you have a warrior, a wizard, and let's say a breakable box. Now, later in the project, you want to implement a looting system. When one character dies or a box breaks, it drops some loot. Does this code belong to the character or item class? Maybe not. So with this pattern, you would have a visitor interface and a loot drop visitor with methods like visit with a warrior parameter, visit with a wizard parameter, visit with a box parameter. In the loot drop visitor class, you implement the logic of dropping the actual loot. And in each character or item object, you implement a new interface that you call, for example, lootable, and each implementation just calls visit this. This is OOP. This knows the type and it will match the right method in the visitor implementation. And in terms of OOP, this is as OOP as it gets. Something it avoids is having if-else checks on types, which is quite ugly, but allowed in C#7. Nevertheless, this pattern does add a few classes as well, and still, visitors don't have access to the private fields, which might be needed in some case. So interesting pattern, but unfortunately this is C tier for me. Alright, that was a boatload of design patterns. I hope you enjoyed this video. I never read so much about design patterns. Yeah, I feel extremely nerdy now. If you reached this far, you are definitely a programmer. No doubts about that. And I will let you in on a dark secret. Design patterns won't make your game fun nor successful. Its only purpose is to help you solve common programming problems. Anyway, the link to the tier maker template is in the description. Feel free to do your own and tag me on Twitter if you fill it out. Great, as always, thank you very much for watching. I will see you next time. Now go work on your game.